Hi, today we will learn about factor trees. We will use factor trees to find the prime factorization of a number. So let us first review that factors are the numbers that we multiply to get a certain number or product. Also, prime numbers are numbers that have only two factors, and those two factors are 1 and the number itself. So, if we are to find prime factors, then we are looking for um, numbers that are being multiplied to other numbers, but they are prime. So most of them are just 2, 3, 5, 7, 11, pwede ring 13 as long as they are prime. And remember, 0 and 1 is not prime. It is also not composite. So now let's look at prime factorization using the factor tree method. So for example, we are to look for the prime factors of 60. How do we do that? Well, we could make a branch out of below 60, draw those branches, and below them, write um, factors of 60. Well, one factor is 10 and the other factor is 6. When you multiply 10 and 6, you'll get 60, right? After that, 10 is not yet prime. 6 is also not prime. So we'll continue drawing branches below them and writing their factors. So how do we get 10? What numbers do we multiply? We could multiply 2 and 5 and we will get 10. 2 times 5 is 10. Also for 6, what do we multiply to get 6? Remember, we'll not use the number 1, so we could not write 1 and 6. 1 times 6. Yes, the other factors of 6 are 2 and 3 because 2 times 3 is 6. Now check the numbers that you've written on the last row. Are they all prime? If they're all prime, then you are done with your prime factorization. So we will continue branching off until the numbers below are all prime numbers. Because 2, the other factors of 2 are just 1 in itself. So it's prime. The other factors of 5 is just 1 and 5. So it's already prime. The same with number 3. 1 times 3 are the only factors of 3. So we are done. But you have to know also that when we do factor trees, we don't have to always start with a specific pair of factors. You could start with whatever factors you could think of. For example, if you have thought that 60 is equal to 5 times 12, that's fine. You could start your factor tree with those two factors. Then check the factors if they are prime. Well, is 5 prime? Yes, we've just said it a while ago. If it is prime, then we'll leave it as is. But we'll check the other factor. Is 12 prime? No, I could still think of other factors for 12, like 2 times 6, or you could even write 3 times 4. But here, I've written 2 times 6. So we'll draw branches below 12 and write its factors below. For 5, since it's already prime, we'll just bring it down. So here we just brought down 5 with one branch. Now check again the numbers that you've written below. Are they all prime? 5 is prime, 2 is prime. So we'll do the last number 6 and we'll write its factors still, which are 2 and 3. 2 times 3. 2 and 3 are already prime, but don't forget to bring down the other prime numbers. Because here below, you will have your prime factors. If you multiply 2 times 5 times 2 times 3, you will get the top number, 60. Here, if you notice, they're just the same. The order is just different. Here I have 1 5, just like the other tree. I have 2 2s, just like here, and 1 3. So the pair that you start with does not really matter. You could start with any pair when you do your your factor trees, but you just have to follow the rule that you have to factor each number until you are left with prime factors. Now, the prime factorization of 60 is 2 times 2 times 3 times 5. They are the factors that you multiply to get 60, and they are all prime factors. That's why it's called prime factorization. You could also write it as an exponent. Since 2 is a factor twice, we could write 2 to the second power. And this is called the exponential form because we use an exponent. Okay? So either way, you could write just use the factor form, but make sure to write it from the least to the greatest. That's a standard way to write the factors, the prime factors. Or you could also use the exponential form. Okay, so now let's turn our books to page 124. We will do together towards better understanding. Okay, we are already given some clues. Oh no, I think I forgot to remove the other clues. Let me turn my book there. Page 124. Number one, we have the number 18, and the clue is one, they started with one factor, 6. But if you notice, the other factor, I've already written the answer, but it's important to notice that it only branched off once, meaning it should be already a prime number. And that number is obviously 3 because I've already showed it to you. Okay, so you check on this level, you check, are they all prime? Not yet. 6 could still be factored by 2 and 3. So we write here at the bottom, 2 times 3. With this prime number, we'll just bring it down. Okay, so the prime factorization of 18 is 2 times 3 times 3. So it's important to bring this down so that you just have to look at the bottom layer of your tree. Diba? It looks like a tree, like a Christmas tree. So just look at the bottom, look at the gifts, and you will get your prime factorization. Or you could write it as an exponent. 3 is used as a factor twice. That's why the exponent here is 2. So either answer will do. Number 2, we have here again the clue that the other factor paired with 15 will be prime because C is only brought down. It did not branch off as with 2 branches. So what do we multiply to 15 to get 30? Yes, it is 2. And 15 is not yet prime. We could still factor it out. 15 is equal to 5 times 3. And we'll bring down 2. So we'll get the prime factorization of 30 is equal to 2 times 3 times 5. I've arranged it from the least to the greatest. Next, on the next page, please write down your answers. I want those pages filled out, okay? Number 3, we already have the clue here that a prime number is written here again. And the only prime number I could think of is 5 because this ends with 5, right? So it's divisible by 5. So you could count by 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 9. So the other factor here must be 9. 9 times 5 is 45, and 9 could still be factored out to 3 times 3. And we'll just bring down the 5. So our prime factorization for 18, it should have been 45, sorry. So 45 is equal to 3 times 3 times 5. And on to number 4. Again, the number that you should write here should be prime. This ends with 0. What could it be? Could be 2. That would be fine. But it could also be 5. What did I write? I wrote 2. So if we write 2 here, what should be its pair? 2 times what number is equal to 20? Yes, it must be 10. But if you write here 5, because it's prime, what should be the pair of 5? It would be 4. And if you do that, you would see you would still arrive at the same prime factors at the bottom. You could do that for your book. But here, I've started with 10 times 2. So I'll finish this. 10, I'll just bring down 2, and 10 is equal to 5 times 2. So the prime factorization of 20 is 2 times 2 times 5. For number 5, we have 18. And we already have the clue that one of the factors is 9. So a clue here is that it would be a prime number. Well, I've already written the answer. It's 2 because 9 times 2 is 18. Then we'll just figure out what are the factors that should be written here below. What do we multiply? What numbers do we multiply to get 9? And what should be written here? Do you remember? Please do that and write your answers in your books. Here also, finish the prime factorization here below. For number 6, we have a clue here that it is a prime number. Well, this is an even number, so it must be divisible by 2. And 2 is prime, so that's a possible answer here. If this is 2, what should its pair be? 2 times what number is equal to 28? And then factor it out. And this one should bring down your prime factor. Okay? Oh, I've given it to you already. It's 14. So write down the last um, layer of your tree, or you could think of it as the gifts under the tree, and write out the prime factorization for 28. Okay? For the follow-up practice, you are to do this. It's written on pages 125 to 126. You have 6 items also, and you are to do the same. Use the factor tree method to find the prime factorization of each number. So here in the boxes on your learning guides, because there's no space in your book, I want to see your factor trees here and the prime factorization here at the bottom. Okay? You could play back our video to check out how I did it or how it is done, the factor trees. Okay, so if you have any other questions, you may always contact me through the Google Classroom. Okay, that would be all. Goodbye.